Howdy! Today we are going to be doing an asynchronous case study on vultures. This case study will perfectly align with our section on ecotoxicology or environmental toxicology. And what we're going to learn is we're going to practice applying the scientific method to an environmental problem. So I'm particularly fond of this case study because I wrote it several years ago when I was learning how to teach with case studies. And so I hope you find it engaging and interesting, and we get to learn about a variety of things with some hands-on real-world issues. By the end of this case study, students will be able to apply the scientific method to critically evaluate environmental data, explain the IUCN Red List and the concept of keystone species, interpret dose-response graphs to find an LD50, and extrapolate the significance of a wicked environmental problem, specifically pharmaceuticals in the environment, and how that relates to their individual lives. Now in handout number 1, Mira mentions her Parsi background and the Zoroastrianism tradition of using towers of silence. This is a fascinating cultural practice where vultures act as natural detritivores. While if it's a wonderful example of human culture interacting with nature, I want to clarify something. The religious practice itself is not causing the vultures to disappear. The cultural context is simply how Mira first noticed the problem and Mira's connection to vultures. The actual threat to the vultures is entirely different. It's a systemic issue, and that's what we're going to investigate today. In present-day Zoroastrianism, the Farvahar is said to be a reminder of one's purpose in life, which is to live in such a way that the soul progresses towards the union with the supreme divinity. Although there are a number of interpretations by individual elements of the symbol, all of them predate the 20th century. In the story, Mira wonders if her childhood vultures are on the Red List. But what exactly is the Red List? Maintained by the International Union for Conservation of Nature, or the IUCN, the Red List is the world's most comprehensive inventory of the global conservation status of biological species. What makes the Red List so unique is that it doesn't just cover mammals, amphibians, and reptiles. It also includes fungi and plant species. The Red List characterizes species based on their risk of extinction, ranging from least concern, like the snowy owl or the Manchurian hedgehog, to vulnerable, like the African elephant, all the way up to critically endangered, like the black rhinoceros or pygmy raccoon. But when you look at these species, what sticks out to you? It might be that they're cute, well known from their favorite childhood storybook, or otherwise likely on someone's list of favorite animal. These are what are often called charismatic species because they are popular, highly recognizable animals, and often highlighted by environmental organizations to generate public awareness, secure funding, and drive conservation efforts. When charismatic species serve as a way to boost funding for conservation and protection of the ecosystem to the benefit of all species in that ecosystem, we often refer to these species as umbrella species because they are acting as an umbrella that helps promote protection for all the species that live near them. Who else is on that list, though? That's not so cute and cuddly. In our case, we are exploring old world vultures. 3 species of vultures we are looking at are the oriental white-backed vulture, the Indian vulture, and the slender-billed vulture. All are classified by the Red List as critically endangered. They are on the list because their population dropped 90% in less than 10 years. But what happened? What caused this massive population decline in these birds of prey? And why does it matter? The decline of old world vultures is highly significant because vultures are a keystone species. A keystone species is a species that exerts a great influence on their community composition and structure regardless of their population size. Keystone species get their name from the keystone of an arch. A keystone is the wedge-shaped stone at the top of the arch that holds the structure together without glue or binding materials. Just as the keystone arch holds the whole structure together, a keystone species exerts a strong control in its community that's disproportionate to its population size. Think of the classic example that we looked at previously in the course of sea otters. Sea otters keep the population of sea urchins under control, which allows the kelp forest to flourish and provides an ecosystem for all those organisms that need it. When you pull the keystone out, the entire ecosystem structure crumbles. So what happens when vultures are removed from an ecosystem? Vultures serve as a detritivore, or species that consume dead or rotting organic matter. When vultures drop out of an ecosystem, who fills that void? Carcasses of dead livestock and wildlife are left out in the open, and in India, this led to a massive explosion in the feral dog population. More feral dogs directly translated to a skyrocketing number of dog bites, which caused a devastating surge in human rabies cases, leading to increased human mortality and millions of dollars in healthcare costs. This is a stark reminder that ecosystem health is human health. While we're discussing rabies, please remember to never touch a wild animal with your bare hands if you can avoid it. Bats can be found at Texas A&M's campus, and so please, if you find one, notify the proper authorities and do not try to deal with it yourself. While you might not be as concerned about rabies because you very well likely have easy access to the rabies vaccine, let's think about our case study, which is happening in the old world of India, Afghanistan, and Pakistan. In these areas, in rural places there, it can be hours or even days of travel to get to the nearest health clinic, and it's not guaranteed that that vaccine is going to be available. Also, it's multiple shots that you need to take over and over again. So without treatment, it's also important to know that rabies is 100% fatal. Now we will begin applying the scientific method to solve this environmental mystery. First, we should consider our observations. You learned about these when you read handout number 1. Next, you consider what your question is. And lastly, at this stage, I'd like you to write your hypothesis for what's vexing the vultures. We are now at our first interactive break. Please pause this video and use the prompt on your screen to submit your initial observations, questions, and hypothesis for what might be causing the sudden massive decline of vultures. Once you've submitted your thoughts, resume the video. There's a possibility that you also might have a prompt within a different learning system of where to put your responses. So please follow the instructions provided.